Hi, let's talk about electromagnetic radiation. Electromagnetic radiation is a wave-like property. It has alternating magnetic and electric fields. Now, we're not going to talk about the electric and magnetic fields too much, but the wave nature is important to us. What are the properties of waves? Well, we're all familiar with waves. We've been to the beach. We've seen waves come in from the ocean. What are the properties? Well, there's a speed that the wave moves. If you see a surfer and he catches a wave, the speed that the surfer moves riding the crest is the speed of the wave. We write that down on the board as a sine wave. That'll designate our wave-like property. And if it travels in a certain direction, we'll give that direction of travel and we'll give it speed. When we talk about electromagnetic radiation, it moves at the speed of light, as opposed to the speed of a surfer. So the speed is the speed of light. What other properties do waves have? Well, there's clearly the separation between the crests of the wave. If you see one surfer catch a wave and another surfer catch the wave right behind him, the separation between those two surfers as they approach the beach is the wavelength. And their speed will be equal, and their distance will stay about the same. Their distance between them, the wavelength. The length between the crests is given the symbol lambda and is the wavelength of the wave. Here's an example, 700 nanometer wavelength. That wavelength corresponds to a wavelength in the visible region of the electromagnetic spectrum, visible light. And I'll often use the term light and electromagnetic radiation interchangeably. 700 nanometers, when that electromagnetic radiation strikes our eye, appears reddish. Electromagnetic radiation with wavelength 400 nanometers appears bluish. So different wavelengths have different properties, and for some electromagnetic radiation, our eyes are sensitive to them. So we have different colors for different wavelengths. Another property of waves are the frequency. The frequency of the wave is how often a wave crest passed you. So if 3 wave crests passed you per second, the frequency would be 1/3, or 1/3 of a second. Now, we say reciprocal seconds, 1/3 seconds, we give that a special unit called hertz. 1/3 of a hertz is 1/3 seconds. The wavelength, the frequency, always multiply together to give you the speed. Product of the wavelength and the frequency is the speed, and for electromagnetic radiation, that's the speed of light, 3 × 10⁸ meters per second. We're going to talk about waves, electromagnetic radiation, and light all the time in this course, so we should be very familiar with the relationships between electromagnetic radiation, frequency, wavelengths, and speed.